Hey everyone, I'm Karthik, and before we begin, I would like to, introduce myself. Like I said, my name is Karthik, and I'm an Android developer, and I've been with Cognizant Softvision for like 1.5 years, more than 1.5 years. And today I'm going to talk about how to build Android apps using machine learning kit. So before I begin, I would like to explain why I chose this topic and the target audience. So I chose this topic because MLKit is very new and it's very interesting, and you can build a lot of cool applications with it. And the target audience is this is for developers who have some knowledge of building Android apps, like with MVVM, and they have good knowledge of lifecycle aware components like live data, and also they should have built some basic applications in the past. And also, if you're new to Android app development, you can just have a glance at this talk, and definitely you'll be having something or the other to take away from this particular talk. And so, what this talk is not about. So, it's not going to be about, although the title says ML Kit, but this talk is not going to be about, machine learning concepts like neural networks, or maybe algorithms, or maybe, the different models which are there and how to train them. It's not going to be about them, but it's going to be about how you can leverage and make use of the ML kit, and also also a bit of image analysis and image processing is going to be covered as part of this particular talk. And so mainly this is for, like I said, how you can make use of the ML kit and the APIs which it provides. And so I would like to begin, with end in mind, like with having set up the boilerplate. Yeah, so I mean, this in this talk, I'll be covering, like the definition of machine learning and its applications, and the various tools which are there to build Android apps with ML, and also ML kit capabilities, all the various APIs which are there under ML kit. And in particular, I'll be talking about the post detection API, which is under beta right now, and I'm still working on it. And also a few other tasks, that I have worked on as part of my research with ML kit. So what is machine learning? So we as humans, we expect ourselves to learn from experience. So similarly, we want our apps or machine learning systems to learn from experience, or without being explicitly programmed. So we want them to improve from experience. So based on the past data which that is being provided. So that's pretty much it. Like, you have to learn from like we humans learn from our experience. Similarly, we want the machines, just to reiterate, we want the machines to learn from experience, or data. So with that being said, like, I would like to cover the applications of machine learning. There are a lot of applications. So one of them which I like the most is, although it is a bit like, I would like to digress from this topic. Like, one of the examples is product recommendations systems. Like, if you log into one of the e-commerce apps, and if you feed in some data, and based on that, you'll be getting some ads related to that particular search string. So that's one of the applications of machine learning. And other than that, we have email spam and filtering, for that we can use machine learning. And yeah, so as far as Android app development is concerned, there are a lot of tools which are available for, a lot of tools which are there for bringing ML machine learning into play. So we have things like MLKit SDK, which I'll be covering quite a bit. There are things like TensorFlow Hub and TensorFlow Lite Model Maker, and also you can add custom models to your, create custom models and add it to your Android Studio projects. So I'll be covering or talking more about MLKit SDK. I won't be covering how to create models and how to deploy them to your Android Studio project, because it's really, I mean, it's very tedious and requires a lot of, I mean, not tedious, but requires a bit of research. And I have done basically a good amount of research on the ML kit, so I'll be talking about that. And ML Kit, it provides a bunch of like APIs. Like I said, these are broadly classified into two of them. One is Vision APIs and Natural Language APIs. And under computer vision APIs, there are things like scan barcode and text recognition, facial recognition, which I'll be talking about in a bit. And also under natural language APIs, there are things like like text translate and extract entity. So like under vision APIs, like I said, there are barcode scanning. So it can be used for all the vision APIs. You'll have to use your phone camera. So you can, using your phone's camera, you can scan the given barcode, or it could be a QR code as well, and you can scan it and get relevant data out of it, or you can pass that data to a backend service and get some relevant data. And in face detection, there are things like you can detect facial landmarks, like whether you can detect whether you can conclude or classify whether the person is smiling or whether he's sad. So for all this, you'll need your phone's camera for it. And other than that, there are some image labeling APIs as well, and it will come with inherent machine learning model. And other than that, object detection and tracking is one of the APIs which under Vision APIs. So under object detection and tracking, you can detect up to 5 objects, I guess, if I'm not wrong. So that's the difference between image labeling and object detection. Although I haven't done deep research on this, because there are like totally, if you have a look at the MLK, there are like 14 to 15, APIs. So I have worked more on the post detection API. So for now, like let me just cover, the text recognition and digital ink recognition at a very high level. So text recognition, like if you just place the phone, if you just place the app and launch the camera, and if you just place it, on some text, it will start recognizing text. And digital ink recognition is for hand from the handwritten, like if you write something on your digital surface, then it will get detected. So these are already being used in a lot of apps, especially digital ink recognition and also even text recognition. These are already there in these are being used in a lot of Android apps. So yeah, so so I would now like to talk about post detection, because this post detection is what I have worked on completely. And this post detection is, like it is in beta right now. It's not yet it has not been released completely, so it is in beta. And also selfie segmentation, like it's somewhat like Zoom, you can only the user's face, like user will be visible, or the person will be visible, and rest of the screen will be covered with uh, rest of the screen will be covered with some arbitrary image. So that's pretty much it as far as selfie segmentation is concerned. And I'd like to talk about the other second set of APIs. Other than the computer vision APIs, we have natural language APIs, and these are like firstly, we have language ID, on-device translation, and smart reply, and also we have entity extraction. So under language ID, you can again scan the you can use your camera, and then you can scan the text, and it will let you know which language or locale the text is from. So, and other than that, under smart reply, these are already being used in some of the apps, like some of the chat apps which are there. And entity extraction, you can, like, if there's a text which is there and you want to extract just the address or just the just the address or just the phone number from the text, then you can use entity extraction. So from now on, I'll be focusing more on the post detection API, because this is something which I have worked on, and I have it is in beta, like I said, and like all other ML-Kit APIs, this post detection API is cross-platform. That is, it can be used on Android and iOS as well. And under full and other than that, it provides like using the camera, it will provide a bunch of landmarks, 33 landmarks, right from the eyes to the foot. So it will provide a bunch of landmarks, and it will populate it onto the screen. And this is called the full body tracking. And after that, once you do the tracking, you will get some there's a variable called in-frame likelihood. So this is it's like a confidence meter. Like, it varies, its value varies from 0 to 1, and if it is really, it's like 0.9. If it is like 0.99, that means it has detected the joint, let's say the left shoulder or the right shoulder, or even any other landmark, it has detected it properly. And there's also a Z coordinate or a Z coordinate, which is for depth analysis. That is, if the value is negative, that means it is behind the hip. It is perpendicular. The Z coordinate, Z coordinate is perpendicular to the hip, and it passes through the hip perpendicular to the camera. So yeah, I mean, I have worked on this post detection API, and but to understand this is what like is there in the documentation. I've just summarized this in the form of a flow chart. So if you can see, before you start working, you have to add dependencies for the post detector API, and then you create an instance of post detector API, post detector class, and then you have to select either stream mode or single mode. So under stream mode, under single mode, it is single image mode. It's like you can select just one single image, one static image, and it will perform post detection, and it will select the most prominent person in the picture, and it will perform post detection for that particular person or person in the picture. Whereas in the stream mode, it is like as soon as you turn on the camera, it will start detecting, with like, as if you make any movements, if the person who's in focus makes any movements, similarly the the post detection will change. So that's like the live stream mode. And after that, you have to you have to process the input image. You have to pass it to the process method, and finally you'll get 33 landmarks, and that's pretty much the flow which is mentioned in the documentation. So if you're using Camera X, which is one of the Jetpack libraries, you'll have to use MBBM for it, which I'm not going to cover. MBBM is like a model view model, which is the state of the art for building Android apps today. So that's like at a high level. But if you're using Camera X, you'll have to use MBVM. But and other than that, what I would like to say is there is a machine learning. There's an ML kit, a sample code base, which is available, and that is not implementing what is there in the documentation. It is something else. So you have to really research, and like, you need to be at least an intermediate Android developer to start working on this ML kit, or especially the post detection API, which is in what can I say, in beta state. And yeah, so I'll be talking about these steps one at a time, like right from the beginning, from this particular step. So yeah, this first, before this you have to add the dependencies, and then create an instance of post detector. Okay, and you have to pass the options. So options, like I said, it can be stream mode or it can be single image mode. So so you have to select one of them, and you have to, not both, you have to select one of them, and you have to pass it to the post detection class. So once you add the dependencies, you'll get a set of classes which you can use. So this is the post detection class, and we are not worried about we are not concerned about the inherent working of this. Just one method, and it will perform relevant. By reading the documentation, you can just get to know that it will perform the relevant task. And other than that, yeah, we have to press. Second step would be to prepare the input image. So in the input image, it can be of different types. Like it can be a file, or when it is a file, it can be a a video, and these are other formats. And then we have to pass the input image object to the post detector. So yeah, I mean, this is where the computer vision or image analysis comes into picture. So we don't really need to delve and drill deep down into the what can I say, the code. And finally, once you process the image, you'll get some results. And so the result will look something like this. I mean, this is it. Like you'll get a set of 33 landmarks, and you can perform analysis, image analysis on it. So these are the enums, and this is the pose, pose variable, which is of class pose, and it'll start you'll get some details related to the post. And now if I want to perform sorry like yeah, so far I have covered it's about post detection. It's not about we you might be wondering where is machine learning in all this. But machine learning will come into play for post classification. So for post classification, like you can see on the right hand side, if using a bunch of image samples, and you can create a model, and then you can integrate with the Android app, and then you can like detect if the pusher is perfectly if it is a perfect one. If it is a perfect one, then increment the counter. So for this, we are using some algorithm called KNN, K nearest neighbors algorithm. I won't delve deep down into it, because this talk, it's beyond the scope of this talk. And other than that, yeah, here you can see there's a guy who's performing sit-ups or squats, and yeah. So I'm still working on this machine learning models, and how to create relevant machine learning models, and for something which I'm like for some sports related thing, which I'll be covering in the next slide. So there are some tasks which I've worked on. So first task is how you can compute angles between your joints, between the landmarks. So if you want to compute the angle between the landmarks, so let's say this is the left shoulder. Sorry, this is the right shoulder of the guy, of the person. Then we have the elbow, and then we have the wrist. So how to compute the angle between these landmarks. And also you can compute something called as landmark recognizing, you can calculate the distance. Let's say if your hand goes above your eye level, then you should like indicate that you should perform some task, or indicate that it is above the eye level, but it should be below the eye level. So there are certain like so there's a formula for it, and this is the one which is mentioned in the documentation. And so you need to this is the method which is in Kotlin. So nowadays, all the apps are using Kotlin, or a combination of both Java and Kotlin. So this is the Kotlin code for computing the angle between the joints. So you just need to pass the post landmark, whether this will be the angle between the hips, like shoulder, hip, and knee. Shoulder, hip, and knee. So this will be the angle made by the hip. So I'll just quickly show you one like task which I have worked on. So It's mainly related to one of my favorite games, which is not only for me but for everyone. So you can see here I have just selected. This is basically the app. Once you run the app, you'll get a drop down, and that drop down you can using that drop down you can select multiple options. So this one, in this case, I have selected post detection, and then when you select an image, you can select one image from the gallery, and this, in this case, static image is being used. Like we discussed, there are two image modes, right? One is stream mode, another one is static image. So basically what is happening is like here you can see this is computing the angle between a left elbow. So left elbow is this one, so this is the angle made by the left elbow. Then we have the right elbow, then the hip, and similarly for landmark, calculating landmarks, like if you can see, this left wrist is higher than left shoulder, so it says false. So left wrist is higher than left shoulder, so this is no, so that's why it's showing false. So basically you just have to play around with the y coordinates of this particular landmark. Similarly, you can have a look at this. Right wrist is higher than right shoulder. So yeah, right wrist is this one, and yes, it is higher than the right shoulder. So it can be used for what can I say? It can be used for a lot of other things. There's some case study which I'm going to perform. So I like a lot of research and development which I'm doing. So it can be used for follow through correction of for spin and fast bowlers in cricket. So let's say there's a bowler and he releases the ball, and then he's not follow through well. So if you use if you for that, you need a machine learning model which will follow through, which will help in which will detect and say that that the bowler is follow throwing well. So you need a bit of image analysis, a lot of images, and then you need a model for it. So I'm currently in I'm working on that. And other than that, I would say it can be used for release point correction. So if you just see the side angle of this, although I don't have a picture for the side angle, so if you just take the side angle of this, it can be used for release point correction for for the bowlers in this sport. And also real time no ball detection can also be done, but not when the bowler is has crossing the popping crease, but it will be very difficult because to calculate no ball in real time. But it can be used when it can be used for detecting no balls when the bowler goes wide of the crease. So, and other than that, I'm working on this. What is it called? Yeah, post detection and classification for a recorded video. So, for a pre-recorded video. So we have seen for a live stream, and we have seen for a static image. So we can do it for a video as well. And also we need some data set for post classification and different models for sports, not only cricket but any other sport. So currently I had a look at the TensorFlow Lite hub, but not many models were there related to the related to sports. And yeah, so that is what is hindering my research as of now. And these are the other useful links. Yeah, I mean, if you want to get started with ML Kit, or you just want to know what are all the capabilities which are there in Android for machine learning, you can use these links. And yeah, I mean, that's pretty much it from my side. If there are any questions, do let me know. I'll try to take them and answer them to the best of my abilities. And yeah.
Thank you, Karthik. We'll have a couple of questions. Karthik, I guess there are no questions.
Okay. Okay. Thank you. Yeah.